Hi everyone. In this video I just wanted to talk about how to do conversions between the mass, moles, and the number of atoms or the number of molecules when we're doing conversions, and talking about how you don't have to rely on memorizing formulas to go back and forth between these units. So I just wanted to show you how to do that without having to worry about memorizing formulas. First of all, the general equation that we are going to use throughout this is this. You're going to have your given units to start, what they give you, and it could be in grams, it could be in moles, it could be in atoms or molecules. Then you're going to multiply by a conversion factor, which is always in the form of a fraction. And that's going to be equal to what you're looking for, so the unknown unit. Okay, so that's the general formula for converting. As I said, conversion factors are in the form of a fraction, and it's basically any equivalent conversion that we're looking at. So for instance, we know that 1 mole is always equal to 6.022 times 10 to the 23 atoms if we're talking about individual elements, or molecules if we were talking about a compound. This is a conversion statement. To make it into a fraction, you're just going to put 1 mole over 6.022 times 10 to the 23 of whatever you're looking at, atoms or molecules. But you can also write it with the 6.022 times 10 to the 23 on top and the 1 mole on the bottom. The decision point is which one of the factors to use. Which one are you going to put on top and which one you are going to put on the bottom. So that's your conversion factor that you put here. Let me go through 3 examples showing you how to go back and forth between these units. Before I do that, I just want to explain one thing. You may have to multiply by more than one conversion factor. How do you know when you need more than one conversion factor? Well, to go from grams to moles, that's just a jump of 1. So that's just going to be 1 conversion factor. Same thing with moles to atoms and molecules. It's just a jump of 1 if you're looking at this. And you can go back and forth and it's still just going to be a jump of 1. However, if you're going to skip over moles and go right from grams to number of atoms or number of molecules, that's going to actually take you 2 conversion steps. You can't go right from grams to atoms and molecules. You're going to have to go from grams to moles and then moles of atoms to molecules. Our number of atoms and molecules, and that's the same thing going in the opposite direction. So 2 conversion factors that you have to go by. Now, one other thing, your given units, if you're going in mass, has to be in grams. So if you're given anything else other than grams, like kilograms or milligrams, you're going to have to convert from that to grams first before you can do anything else. And the conversion factors for that are 1,000 milligrams equals a gram, or 1,000 grams equals 1 kilogram. So that's just an added conversion that you need to do if your mass is not in grams. Okay, let's look at our first example. So here's our first example. A pure gold coin contains 0.133 moles of gold. So this is what we're given. What is its mass? That's what we're trying to find. So if we set up our standard equation, we write what we're given first, 0.133 moles of gold, and the element symbol for gold is AU. And then we're going to multiply by, we're going from moles to mass here, right? So we're looking at 1 conversion factor. So my conversion factor is in the form of a fraction, is equal to the mass, which is going to be in grams. So that's how you set that up. And then you have to look at what conversion factors we're going to use. Our conversion factor has to be moles to our mass in grams. And we know that 1 mole of gold is equal to 196.97 grams of gold, which we find through the molar mass on our periodic table. We have to turn this into the fraction, and the question is, what goes on top and what goes on the bottom? Well, what goes on the bottom is always what's going to cancel out your given units so that you're left with what you're trying to find. So if we're trying to cancel out mole, we're going to put that on the bottom. So 1 mole of gold is equal to 196.97 grams of gold. Another way to say that, so as you can see they cancel out, or another way to say that is whatever you're trying to find should be what's on top in terms of grams. Now that I have my equation, I now multiply the top and then divide by the bottoms. So 0.133 times 196.97 grams divided by 1 is equal to 26.2 grams of gold. That's our answer. Let's look at another example. So our next example is how many atoms are present in 2 moles of nickel. So this is our given, 2 moles, and we're trying to find the number of atoms. So that's what we're trying to find. So we're going from moles this time to number of atoms, and you can see that it's just going to be one conversion factor to get us there. So our given units is 2 moles of nickel times a conversion factor is going to be equal to our number of atoms. The conversion factor we're going to want to do is moles equal to atoms. And we know that 1 mole of anything is equal to 6.022 times 10 to the 23 atoms. Again, this needs to be turned into a fraction. What goes on the top is what we're looking for, so it's going to be 6.022 times 10 to the 23 atoms. And what goes on the bottom is the unit that we are trying to cancel out. Then we just have to multiply straight across. 2 times 6.022 is equal to 12.04, and then times our base of 10, 10 to the 23 atoms. So again, that's just one conversion factor that was needed, and knowing what units to put on top, that's going to be the unit in your answer, and what unit to put on the bottom of the conversion factor, that's going to be the one that you cancel out. Okay, let's look at the more complex question where you have to use 2 conversion factors. So here's our last example. How many atoms are present in 46 grams of boron? 46 grams is our mass, and that's what's given. We're trying to find the number of atoms. And so when we set up our equation, we're going to have 46 grams of boron, which is the chemical symbol B, times our conversion factor. Now we're going from grams to atoms here, so we're actually doing 2 jumps. So it's going to take 2 conversion factors in our multiplication. And then that's going to be equal to our, what we're looking for, which is number of atoms. So the first thing we have to do is go from grams to moles. So grams to moles. And we know that 1 mole of boron has a mass of 10.81 grams of boron, and we find that through the periodic table. So our first conversion factor is this grams to moles. Because we want to cancel out grams, our grams of boron have to be on the bottom, leaving us with moles of boron on the top. So 1 mole of boron is equal to 10.81 grams of boron. That's our first conversion factor. Once we do this, we have the moles, and now we have to go from moles to number of atoms. And we know that 1 mole is equal to 6.022 times 10 to the 23 atoms. So we're going to put the mole on the bottom because we want to get rid of it, and we're going to put atoms on top because that's what we're trying to find in the end. And that's our equation. So a little bit more complex because it's 2 conversion factors, as shown here, that we had to go from mass to moles and moles to atoms. There would have been 3 conversion factors if we had to convert first from a unit other than grams to get it to grams, and we can just add as many conversion factors in as we need to. Now we just go straight across. We get 46 times 6.022 is equal to 277.01. We're going to divide that by 10.81. That's going to give us 25.6 times 10 to the 23 atoms. But this is not in proper scientific form, scientific notation form. We have to move the decimal over 1, so there's only 1 number in front of the decimal. And because we moved it over 1, we're going to have to add a power to this, because now we're going to go from here. It would be 23 decimals that we had to move, but from here it's going to be a total of 24, 1 extra, to get the actual number of atoms. And that's our answer. So when you're practicing these questions, really think about setting up this standard equation, thinking about how many steps you need to go in order to convert between these units, remembering that to go from mass to number of atoms and molecules, or number of molecules and atoms to mass, is 2 conversion steps. But if you can get used to looking at questions this way, you won't have to memorize formulas. So I hope this helps, and good luck in your practice. Bye for now.